Talking about centrifugal compressors, the process engineer will deal with a variation of documentations, for instance, the vendor's manual, the list of alarms and shutdowns, but one of the most important documentations to be evaluated in the phase of purchase of the equipment is the performance curve or the data sheet of the compressor and also the PNID. Here in the screen, you can see an example of a data sheet of a centrifugal compressor. The interface or the layout of each data sheet will depend on the supplier. In this case, we have the inlet conditions and also the operating point. The inlet conditions is informed by the chemical process engineer in the process data sheet of the equipment. As I mentioned to you, we develop the heating material balance, transfer the results or the results that interest for the equipment to a process data sheet, and other disciplines add information to a specification data sheet in order that we can do the quotation of the equipment and eventually the purchase of the equipment. So besides the information of the RPM of the compressor, the others information here is information added by the process engineer. The gas composition, in this case is air, the ambient pressure or the barometric pressure, the inlet pressure, the inlet temperature, and the inlet or the coolant temperature available for this machine. On the other hand, the operate point, some information here is informed by the process engineer. For instance, the desired pressure at the outlet is information from the process engineer. The flow of fluids in this equipment is also information added by the process engineer, but the power calculated in this case is responsibility of the vendor because it depends on the efficiency of the machine. That is a responsibility of the vendor. The specific power is by vendor, the rise to surge is by vendor, and the turn down is by vendor also, and the ratio to max flow is also by vendor. And here, most similar to a centrifugal pump, we have here the compressor curve. So I have the surge curve here where I cannot operate above this range because I will be in the surge conditions. And for each line here, I have a condition of opening from a guide vane. So the guide vane is responsible to add more or less flow to my equipment. The guide vane will add a pressure drop to the equipment in order that I can choose the range of operations. And in the operating point at the 10,930 normal cubic meters per hour, I have a guide vane opening of 49.7. So this is my operating range, and based on that I reach the desired discharge pressure. If I want to have a lower flow in my equipment, I will change the guide vane opening, for instance, for 60, and I will operate at this range here, and I can verify what are the new conditions in terms of performance. So here, based on the opening of the guide vane and of the flow of the fluids in the equipment, I have a requirement of power.